This will be another easy one, and if you notice that what we're going to be looking at is an x and minus 1 times x. Now we're influencing the x value. And the question is, what does it do? Well, it's going to flip the graph around the y-axis. Why? Because you're multiplying all the x's by -1. And it changes all positive x values to negative and all negative x values to positive. So it takes the graph, flips it around. So we're going to call this a reflect the y-axis. And it's f of minus x. And you notice the impact is take -1 times the existing x value. So that adds another one to your chart. We now have 4. That means we've got 2 more. So that if we're looking at the graph and we're multiplying the x values by -1, it's going to flip the graph around the y-axis. It's a reflection around the y-axis. X value is being multiplied by 1. If we look at the examples, f of minus x, the quantity squared. Or g of x equals the square root of minus x. H of x equals the absolute value of minus x. Or j of x equals the opposite of x cubed. By the way, with everything but the square root, it does not matter. And you're going to say, why? Well, because if I were to take a look at just essentially the opposite of x, the quantity squared, this is the same as -1 times x squared, which is the same as -1 squared times x squared using the property of exponents. And what you're going to get out of this is just x squared. It doesn't make a hill of beans difference. Same thing with the absolute value of negative x. Absolute value of negative x, that absolute value is going to kill that negative off. If I look at x cubed is -1 times x, the quantity cubed, which is the same as -1 cubed times x cubed. That brings the -1 out in front of the x cubed. So it will look like exactly like flipping it around the x-axis. So with the polynomials, you're going to find this particular reflection makes not a bit of difference. With some other functions, when we run into, say, the logarithmic functions, it will. Square root, it will. But only certain functions, this particular transformation will have an impact. But we'd play with it just like it were real. If it's on the inside, it's on the inside. The transformation is of the form f of minus x. So it's on the inside, and it's going to be performed by taking -1 times all the x values. So now we'll perform the transformation on one of the ones where it makes sense. The basic function, in this particular instance, we have g of x equals the opposite of the square root of the opposite of x plus 2. Who's the basic? Square root of x. If I start from the inside, that's my first transformation. What is it? It's -1 times x does what? Reflects the y-axis. And you should have that on your white sheet of paper. I'm done on the inside. I come to the outside. That's the second step. What does it do on the outside? Reflects the x-axis. Then I've got this stinking +2 hanging off the end. What does he do? Moves it up 2. So that says this guy is what? Upside down, backwards, up 2. Right? Upside down, backwards, up 2. So, first step in the transformation would be to reflect the y-axis. Second step in the transformation is to reflect the x-axis. Third step in the transformation is an up 2. And then remember, once I hit the outside, this is all x's, this is all y's. Reflect the y-axis, I'm going to take -1 times the x values. Reflect the x-axis, -1 times the y values, up 2, I'm going to add 2 to the y values. So that's my order. So the first thing that I'm going to need is, the domain is 0 to 4, because remember, you can't take the square root of a negative number, so the domain for the square root starts at 0. So 0, 0, this is x, square root of x. 1, 1, 2, 1.4, 3, 1.7, and 4 is 2. Do enough of those, you remember that. First thing I do is I want to reflect the y-axis, and I do that by multiplying -1 times all the x's. So 0, -1, -2, -3, -4. I've just changed the domain of this function. The domain now goes from -infinity to 0 instead of 0 to infinity, because that minus sign flips it. So now I'm flipped backwards, and then I'm going to move to the y side, and I'm going to multiply the y's by -1. That's going to turn him upside down. So 0, -1, -1.4, -1.7, -2. Now he's upside down backwards. And then I'm going to move him up 2, and that's going to be 2, 1, and now I have to think, 0.6, 0.3, and 0. God, this is a hard one, because I'm not used to thinking backwards. And that's my new set of coordinate points. So, on the new set of coordinate points, we're going to look at 0, 2, x equals 0, y equals 2, 2. 1, -1. So you notice he's going to be upside down backwards. Oh, 0, 2. Oh, Peterson. Why didn't you guys say something? Because you trusted me. Don't trust me. 1, -1. -1, 1. -1, 1. Okay. 2, -2.6. -3.3. -4, 0. So that's kind of what he should look like. Let's see if that's what we got. We said, here's the basic, right? So the basic, we are going to reflect the y-axis. Boop. Then we're going to turn him upside down, reflect the x-axis. Boop. And then we're going to move him up 2. So he should look very similar to this guy. And he does, except for those 2 points in there that need to be erased.